All right, here we have a truly difficult question, okay? I will explain it the way that I see it. If you have a better idea, feel free to throw it in the comments because I think this is one where the more ideas we have about how to see it, the better. First, though, let's get some pictures on our scrap paper because there's no way for me to think about this without seeing this triangle. So let's just follow the first sentence here. In triangle ABC, the measure of angle B is 90 degrees and BD is an altitude of the triangle. So that makes me want to draw this thing this way, where I have a right triangle, but the right angle B is at the top, because for me the word altitude, I just think up and down, right? So you don't have to draw it this way, but that's kind of just in my mind the easiest way to picture it. Then the length of AB is 15 and the length of AC is 23 greater than the length of AB. So let's just put A here and C here. I don't even know if that's accurate in terms of the sizes, but it's okay for our purposes. So AB is 15. And then this is a weird thing to do. AC is 23 greater than AB. So why not just tell me that it's 38, right? 23 plus 15 is 38. So that's this whole side is 38. Weird. But I don't know. I don't know what the deal is there. They want us to find the value of BC over BD. So BC over BD. Now, my first thought in doing this is actually to use Pythagorean theorem to find BC, because we can. However, it's not going to be a nice number, and it's certainly not going to be 15, 23, or 38, the answer choices that are given to us. So now that makes me rethink things. The real thing they're testing here is not Pythagorean theorem, it's similar triangles. And when you have a right triangle kind of split with this altitude, you end up with a lot of similar triangles, 3. And the reason we know that is this altitude is going to be perpendicular. So just like the big triangle, both of these little triangles, the left and right triangles, have left for side, right side. They have a right angle, and they share at least one other angle with the big triangle, right? The left side triangle obviously shares angle A with the big triangle because it literally overlaps there. And the right side triangle clearly shares angle C with the big triangle because, again, it overlaps. And so if we know that two angles in any two triangles are the same measurement, then the triangles are similar. Just by kind of the 180 degrees in the triangle rule, the third angle will also be the same as well. So we got 3 similar triangles. So when they ask us for BC over BD, they're not really asking for BC over BD. They're asking us to kind of line that up with other stuff. So BC, we have to kind of understand how that fits into the big picture. BD, I'm going to highlight both of these in yellow, because when I see BC and BD, I know that they are talking about this right side triangle. They're giving me 2 sides of it, or they're asking me about 2 sides of it. So what I want to do is then find another triangle where I know 2 sides. Hopefully it's the same 2 sides, and then I can kind of line things up. So notice that BC is the hypotenuse of this right side triangle, right? It's across from the right angle. Well, what side is across from the right angle in the other 2 triangles? Well, in the big triangle, it's the hypotenuse is right down here, right? This is my hypotenuse of ABC, right? That's the biggest side. So if that's the one we're talking about, then that's AC on the top. If we were talking about the left side triangle, so this is the big one, this is the right side one, and the left side, then the hypotenuse would be AB, which is 15. So I'm not going to put the numbers there yet. Let's just see what we got. So now, okay, well, what lines up with BD? And this is where it gets a little tricky. Ugh, this is going to get so messy. BD in the right side triangle, we have to always think about what they're opposite, right? What angle are they opposite? So BD is opposite angle C. So I would love to know another side that is opposite either C or something that measures the same as C. So now I have to kind of ignore the altitude for a second, because if I go to the big triangle, then opposite C, I go past that altitude, is this other side that I was given, AB. Now in the little triangle, it's more confusing because we don't have C lined up nicely. In the little triangle, the one that's going to be opposite C is actually down here, AD. And that is just because of kind of process elimination. That we know where A is, we know where the right angle is, so the kind of C angle is going to be in the top there. So don't worry about it because I don't know AD. So I don't want to deal with this left side triangle. It's just not going to help me. But I do know AC and I do know AB. Those are the only two things we know. They're the ones that were given us at the start. So really I can just kind of fill this in. AC was 38 and AB was 15, and that is an answer choice D. To be clear, we are not saying that BC is also 38. That would not make any sense. We are also not saying that BD is 15. We're just saying that because they're similar triangles, the proportion, the relationship between those sides is always the same thing. It always is the same as 38 to 15. So it's going to be different numbers. I don't know what those numbers are. I don't really care. But the overall fraction is the same, which is why even though these are the measurements of the big triangle, we can use them to understand the smaller triangles as well. Hopefully that made some sense. Again, this is a hard question. So if it's tricky for you, don't worry about it. There's so many other easier questions in this section that are better to prioritize. But one other piece of advice is like how would you know that this is about similar triangles, right? Like I said at the beginning, there's a temptation here to do some Pythagorean theorem. And we could do it. We could solve for BC. We could solve for BD because we can get the angles using the trig buttons on our calculator. The reason I didn't do that is the SAT usually doesn't make us use those buttons. So any solution that involves those buttons, I'm very suspicious of. It just feels like that's not the ideal method. So I wouldn't have gone that route just because I know that door is kind of closed on the SAT. But, I know that if I've got triangles, one of the biggest concepts with triangles is that they're either similar or congruent. And because they had me draw a triangle that I then divided into even more triangles, I'm like, okay, we got a bunch of triangles of different sizes. Similar triangles is probably the topic of this question. And this is really helpful because, kind of in the same way that I'm able to close the door on trigonometry, I'm also able to kind of open the door on this because if you study for the SAT and you watch my videos, you will know that there are only so many things that they ask about, right? It's not all of math that you've ever learned, especially geometry. It's a limited list. And so if you kind of know what's on that list, you kind of can just go through the list in your mind when you get a geometry question and be like, okay, what are the things that could potentially apply to this situation? There is some trigonometry on the SAT, but it's very limited. And I knew it kind of didn't matter here. But maybe there is a solution that involves it. But it's just, I got to similar triangles because it was just like the only thing that fit this picture. With practice, you'll get better and better at that. There's just a limited number of things in the test. And this applies not just to geometry, but to all the aspects of the SAT math. So hopefully, as you practice, you will start to fill in that list for yourself and you'll know, like, what are the things on the menu that you can choose from when you get to a hard question that might not be as obvious what it's testing. Here, I literally just kind of went down the only path available and it ended up being the right path.